Hi everyone, we're Team 28 and this is PeterFinder, a UCI-focused lost and found search system. So first of all, what is PeterFinder? PeterFinder is a location-aware search platform built specifically for the UCI community. It lets users report lost or found items and search a centralized database that combines text filters with geolocation-based ranking to display the most relevant results. Moving into our problem and user, with UCI being such a large campus, a common pain point across UCI students, faculty, and admin that our app addresses is being unable to find a lost item. Our app aims to centralize this process and connect users with their lost items as efficiently as possible.
To give an overview of our system, some of our core features are reporting items, searching the database, and filtering by location, item type, and keywords. The UI is a split-pane dashboard with an interactive campus map on the left, showing item pins, and a search and rank results panel on the right. We also have a notification system for when a matching item gets posted. To give an overview of how our search works, the system scores every item using four signals: text similarity for name and description, proximity to the user and proximity to buildings, recency of the report, and category relevance. These are combined into a composite score so that the most likely matched items are always ranked at the top.
Okay, and now I'm going to demo the app. Okay, in the first scenario, let's say I have lost a wallet. I'm gonna go to the lost tab, and then in here, I can input the type of item that I've lost. So with type wallet, we can see all the wallets that have been found throughout the UCI campus. But let's say I want to be a little bit more specific and I want to find a certain color that my wallet was. I can type in the specific keyword, let's say black wallet, and that one shows up. Another scenario is, let's say I found a wallet and I'm trying to see other users and where they've lost their wallets. So I can type in the type wallet and I can filter down by the location. So I'm going to say the Zod and Go market. I'll say wallet. And as you can see that the closest wallet is near Aldrich in the middle of Aldrich. And in the last scenario, we can test out our implicit search where I add a wallet. Let's say I've lost a blue wallet in the middle of Aldrich Park, and I'll just say blue. I'm going to make it the type wallet and add the item. So by adding this item, we can go to my wallets or my items, and we can check and see that we've added a wallet to my lost item list. And it also states that I have 4 possible matches. So in here, we can see possible matches for wallets that match up with me. And you can see all the 4 different possibilities and look through them and see the details and also the finder's email. So you can quickly contact them to get the item. All right.
Okay, so for our evaluation highlights, our approach was to test such representative search queries and filters. And our key results were that the correct matches ranked at the top for keyword searches successfully. And the location filters successfully prioritized nearby items over distant ones. And then category filters further reduced down irrelevant results. And our conclusion from our evaluation was that our ranking effectively combines text, location, and context signals. Okay, for our limitations and future work, our current limitations are that we have a small data set with around 30 items, which limits ranking robustness, and we have no support for synonym matching. For example, if someone types hoodie versus sweatshirt, we don't see that they're similar. And our possible future enhancements include expanding the data set with more user submissions. We can improve ranking with machine learning or embeddings. We can also implement real-time email notifications when matching items are posted, and we can integrate with UCI's existing lost and found services, UCI PD, for a centralized platform. And that was PeterFinder, so thank you so much for listening to our presentation.